Welcome to the class. Today topic is photoelectric effect. Okay. Hertz is a scientist, has performed experiment. In this experiment, he has taken some alkali metals, means potassium, rubidium, cesium. Okay, potassium, rubidium, cesium, like the alkali metals. Potassium, rubidium, or cesium. Okay, he has taken the type of metals and then light is projected on that metal surface. Then he observed some electrons are ejected from the metal surface. So this is known as photoelectric effect. Okay, when light fall on some active metals, not all the metals, these are the active metals, means 1A, alkali metals. So whenever light falls on active metals, it can eject electrons. Okay, he is observed this. This is known as photoelectric effect. Okay, next he was explained this photoelectric effect by taking 3 points. He considered 3 points to explain this photoelectric effect. He was constructed the construction of the diagram is like this: metal surface, active metal surface, light fall on this metal surface, and electrons are ejected. These ejected electrons are measured by this type of arrangement. Okay, one wire is connected battery like this, and this one is connected back to the battery. This is ammeter. Okay, ammeter. Okay, this is the way he can observe. Active metals eject the electrons whenever light fall on a particular metal. Okay, this is known as photoelectric effect. He has observed the photoelectric effect with this type of arrangement, with this type of practical arrangement. Okay, from this experiment, he was explained this experiment. First point: the electrons are ejected from the clean metal surface as soon as beam of light strike the surface. Okay, as soon as light strike on the metal surface, okay, simultaneously electrons are ejection takes place. There is no time lag between the striking of the light beam and the ejection of the electrons from the metal surface. Okay, what it indicates? Whenever light falls on a certain metal, active metals, okay, simultaneously electrons are ejected from the metal surface. There is no time lag between the light fall on the metal surface and electron ejection. So simultaneously it happens. So it indicates the first point. Next, second point is, okay, second point, the number of electrons ejected proportional to the intensity or brightness of light. Okay, number of electrons are ejected like this is proportional to intensity or brightness of light. If you are projected bright light, okay, it is focused, the metal is focused for bright light, then it can emit okay, more number of electrons than compared to the pale light. Okay, brightness is increases, then number of electrons ejection will be greater. Okay, this is the second point. Okay, bright light will fall on a metal surface, then it can eject more number of electrons than compared to the less brightness light. Okay, less brightness light can eject only a few number of electrons. If more brightness of light projected on the metal surface, it can eject the more number of electrons from the metal surface, which is indicated as the number of electrons ejected is proportional to intensity or brightness of the light. Okay, this is the second point. Okay, next, third point. What focus the third point? Third point, what it says? For each metal, there is a characteristic minimum frequency mu naught. Every metal has characteristic minimum frequency. Okay, this is known as threshold frequency. This frequency is known as threshold frequency, below which photoelectric effect is not observed. Okay, below which photoelectric effect is not observed. At a frequency nu greater than the nu greater than the nu naught, the ejected electrons comes out with certain kinetic energy. The kinetic energy of these electrons increases with increased frequency of light used. What is it means? Okay, let us take an example to understand this concept. For example, take one metal, potassium metal, has certain frequency. Threshold frequency is known as 5.0 into 10 raised to the power of 14. Okay, 10 raised to the power of 14 H. Okay, whenever red light is falls on metal surface, okay, electron ejection not takes place because its frequency of red light is 4.6 to 4.3 to 4.6 into 10 raised to the power of 14 H. Okay, the frequency of light is less than this, so ejection of electron not takes place. When the ejection of electron takes place, the light energy should be, the light energy or light frequency should be greater than to the metal which you are taking for the photoelectric effect. So frequency of the light is less than this one, so photoelectric effect is not possible. Okay, when photoelectric effect is possible, is ejection of electrons is possible when the light falls on the metal surface have frequency is greater than the metal frequency. Okay, then only photoelectric effect or ejection of the electrons takes place. Ejection of the electron takes place. So nu of weak yellow light is 5.1 to 5.2 10 raised to the power of 14 H. Okay, it means this energy is greater than this one. So the light energy should be greater than this one. Then only ejection of electron takes place. Then only ejection of electron takes place. If the projected light, when the light is false, that projected light is less energy, the ejection of electrons is not takes place. If it has greater energy, then only ejection of electron takes place. Now there is another question. If the frequency of light, is very high, okay, if it is here, the weak yellow light is 5.1 to 5.2 10 to the power of 14 H. Okay, in case the energy of this one is very high, 6.0 or 10.0 into 10 to the power of 14 H, then what happens? So then what happens means the energy of projected one, the light energy is very high, the light frequency is very high then compared to required metal frequency, threshold frequency. Then the remaining energy is converted into kinetic energy of the electron. So the gap between these two, the projected light energy, okay, frequency and this frequency, okay, this difference is very large. This one is as very large value, then that energy is get converted into get converted into for the kinetic energy of the ejected electrons. This total energy is converted into electrons movements. Electron movements. Okay, then it is converted into kinetic energy of the electrons. So electrons will come out with forcibly, with greater kinetic energy. Okay, the whole energy from this energy minus this energy gives this some certain energy. This energy is utilized for the movement of the electrons. For the movement of electrons. Okay, this is the way they are represented here. The ejected electrons come out with certain kinetic energy. The ejection of electrons come out with certain kinetic energy. The kinetic energies of these electrons increases with increased frequency of light used. Okay, frequency of light. Okay, the ejected electrons come out with certain kinetic energy. Okay, the kinetic energy of these electrons increases with the frequency of light used. If the frequency of light is very high, then the kinetic energy of ejected kinetic energy of electron is very high. Okay, if this frequency of light is equal, if these two are equal, then ejection of electron only takes place. The ejection of electron only takes place, but there is no kinetic energy. The movement of electron is slowed down. Okay, there is a reason why the kinetic energy of the ejected electron, the kinetic energy of the ejected electrons is depend on the light frequency. The light frequency is very high, then the kinetic energy is very high. If it is very low, okay, if the kinetic energy of the frequency of light is less than this, okay, if the frequency of light energy is less than this, then ejection of electron is not takes place. Okay, this is the idea they have given. From these 3 points you can understand very easily in photoelectric effect. Next, there is another point. When brightness increases, number of electrons ejection is increases. Okay, brightness increase means number of photons are increases. Brightness increases, number of packets of energy is increases. Number of packets increases, number of electrons ejection is also increases. Okay, brightness of light increases, number of electrons is increases. When frequency of light increases, the kinetic energy of the electrons increases. This is the main 2 points which you can remember always. Okay, brightness increases, number of electrons ejection is more. Okay, because brightness means number of photons are greater. Okay, electromagnetic radiation has particle nature, which indicates it has number of photons. Okay, number of brightness increases, number of photons increases. So number of photons increases in a particular light, then number of electrons ejection is also takes place, is greater. Next point, then the frequency of light increases. The frequency of light increases. Okay, the frequency of light increases. The increased energy is get converted into kinetic energy of the electron. Electron movement is fast. Frequency of light increases, the movement of electron is fast, and we can say kinetic energy of the electron is greater. Okay, you can understand this way of the photoelectric effect. Next, there is another question has appeared. Radiation propagates. Whenever electromagnetic radiation propagates, it has wave nature only. So, next, whenever these electromagnetic radiation strikes any surface, okay, whenever this electromagnetic radiation strikes any surface, it has particle nature. Okay, so in this way he can explain dual character of the electromagnetic radiation. Dual character of electromagnetic radiation is explained by the scientist like this. Whenever electromagnetic radiation moves in space or somewhere, it moves, on movement of the electromagnetic radiation, it has the wave nature. Whenever this electromagnetic radiation strike the any surface, okay, it behaves as a particle nature. It behaves as a particle nature whenever it can strikes on the any surface. So this is the way they can explain dual character of the electromagnetic radiation. Dual character of the electromagnetic radiation says whenever wave can move freely, it has wave nature. Okay, whenever electromagnetic radiation moves freely, it has a wave nature. Whenever it strikes on the metal surface, it behaves as a particle nature. Okay, these are the two simple points you can understand. Next, you can also understand one point, that is based on photoelectric effect. They are derived on the equation H mu is equal to H mu naught plus of mv square. Of mv square is equal to, this is known as kinetic energy of the electron. This is known as kinetic energy of the electron. Okay, you may write this equation into H mu is equal to work function plus Ke. Okay. Whenever certain light falls on certain metal surface, this frequency is greater than this frequency, then only ejection of electron takes place. If this frequency is greater than this one, then it is the difference of these two energies get converted into kinetic energy. This difference of these two energies get converted into kinetic energy. You may write like this: H mu naught is equal to half mv square. Equal to half mv square. This is known as kinetic energy. So the difference of these two, threshold energy and the frequency of light, okay, these two is known as kinetic energy. Is known as kinetic energy. Okay, they have given kinetic energy like this. Okay, you may write like this: H mu is equal to the W naught is known as work function. It is known as work function plus kinetic energy. Kinetic energy of the electron. When kinetic energy of electron is possible, this frequency, light frequency, greater than threshold frequency, then only this remaining energies get converted into kinetic energy of the electron. Okay, this is the way you can understand the photoelectric effect. Okay, let us focus on a problem, that is the threshold frequency nu naught for metal is this one. Threshold frequency of metal is like this, mu naught. Calculate the kinetic energy of an electron emitted when radiation of frequency nu is equal to 1.0 into 10 to the power of 15 second inverse hit the metal. Okay. Next, this is nu. This is known as nu naught. What is the means of kinetic energy? Let us use the formula from the photoelectric effect. H nu is equal to H u naught plus kinetic energy. What they require is what is the means of kinetic energy. Calculate the kinetic energy of electron. Okay, then you may write like this: H nu minus H nu naught. This one you can write like this also. H is a constant value. H is always constant, is a Planck constant, 6.626 into 10 to the power of minus 34 joules. And the value difference, nu value is 1.0 into 10 to the power of 15 minus nu naught. They have given nu and nu naught. Nu is equal. Let us see nu and nu naught value. 10.0, 7.0 into 10 to the power of 14. Subtract these two, you can get this one, and multiply these two, you can get the 1.988 into 10 to the power of minus 19. So in this way you can calculate the kinetic energy of the electron from the given data. Okay, so you can understand this way. photoelectric effect.